Read the question carefully. So essentially we are trying to minimize the distance from the sun which is located at the origin. So let's say here 0 0, and the path of the comet follows the parabola. There is another point, that's the generic point x, y. So x and y, so y is given by this curve x squared minus 1. Okay, this is the path for the comet and this is the sun's location. So here is the distance. I mean, this distance changes as the x changes, and we are asked to find the x coordinates, the x value, for the minimum distance, which is closest to the sun. So we need to find the distance between these 2 points using the distance formula. I mean, the distance would be just square root of this 1 minus 0 squared plus this 1 minus 0 squared. Okay, this is the distance function, and we want to minimize this to find the closest. Okay, and that happens for 2 x points, x values. So we need to find those x coordinates and the minimum distance. Okay, the distance is given in millions of miles. So here the actual work, I would start with the distance. Let's say d is square root of, so this is from this one we can write x y, which is x squared minus 1, and origin means 0 0, or look at this one. Now x minus 0 quantity squared, which is x squared, plus this one minus 0 squared. Okay, this is the distance formula. We can simplify inside. This is in fact x squared plus x squared minus 1 quantity squared, means we multiply x squared minus 1 by itself. Just FOIL, multiply. You're going to get x fourth minus 2x squared plus 1. And that is now, let me write x fourth first, x squared minus 2x squared minus x squared plus 1. Okay, and we want to minimize this. So this is given in the square root. To minimize, we can take a function without square root so that it becomes easier to work with. So I'm going to take a function as the inside. If this function is minimum, then the square root would be minimum as well. And to find max or min, we always find the critical numbers. That means find the derivative, which is 4x cubed minus 2x. Now we set the derivative 0. That is 4x cubed minus 2x equals 0. From this we can factor 2x out. 2x squared minus 1 equals 0. Okay, from here either 2x equals 0 or 2x squared minus 1 equals 0. Divide by 2, so x equals 0. Add 1 both sides, divide by 2, so 1/2. Now take square root of both sides, so we get plus or minus. Square root of 1 is 1, square root of 2. So we got 3 critical numbers here: 0, negative 1 over root 2, positive 1 over root 2. Now to minimize the distance, let's compute the distance at these 3 points. So let me make a table. X values, we got 0, negative 1 over root 2, or we can take positive first, doesn't matter, negative 1 over root 2. And now we want to evaluate the distance at these x values. The distance is in fact square root of here, x to the 4th minus x squared plus 1. If you read the question carefully, we need to find the minimum distance as well. So let's evaluate the distance. We took the function, but here I want to find the distance. Plug in 0 here, 0 minus 0 plus 1, square root of 1, just 1. So 1 million, million of miles. Okay, anyway, 1. Plug in 1 over root 2 here. Okay, let's do a little bit of work. So square root of 1 over root 2 to the 4th minus 1 over root 2 squared plus 1, because we need to answer in exact form, no decimals. So 1/4, use your calculator, 1 over 4 minus 1 over 2 plus 1. 1/4 minus 1/2 is negative 1/4. Negative 1/4 plus 1 is 3/4. Okay, this is 2 over 4, this is 4 over 4, and 3 over 4, that's root 3 over 2. So plug in here, we get root 3 over 2. Plug in negative 1/2, negative 4 times means positive, negative square means positive, so this will be the same. So we're gonna get the same thing. And this is about 0.866, which is less than 1. So as the question claimed, the comet is closest to the sun at 2 points. We found that at x equals 1 over root 2 and at x equals negative 1 over root 2, and this is the minimum distance in millions of miles. So this comet is closest to the sun, closest to the sun at x equals negative 1 over root 2 and at x equals 1 over root 2, and the minimum distance is, we found, root 3 over 2 million miles. Okay, final.